Okay, we're going to come into the Salt Lake Community College Welding School, and you can see they have a high bay door for bringing equipment and projects in and out. And all the shop floor equipment here, the band saws, the shear machines, drill presses on this wall here, another shear. Got a dispensary for tools and so on here. Those are all the welding booths down there. We're going to surround the welding booths here. Walk around. Got an area in here for manual cutting. And, welding. All the welding booths, 106 welding booths here, fully equipped. Another row of welding booths, lockers. There's the back row of welding booths. Back here, you can see the high bay space for all the ducting and electrical and pipelines and everything required. Welding booths. There you have it. Rod oven here to keep your welding rod dry. And that's it.
Okay, so here at Salt Lake Community College, the class that Liam is enrolled in, we teach them a little bit of everything. They do oxyacetylene welding in various different positions. They do arc welding, some MIG welding, TIG welding, flux core welding. We get them familiar with plasma arc cutters and running torches, and basically we're shooting to get an entry-level position in the job. We do have other courses that expand more like into pipe and stuff like that, but that's on a degree course. And the students that are here now are just looking to get a certificate.
So how many months or time does it take?
It's based on hours.
Yeah.
You can finish at any time, but once you sign up for a single class, you burn through a certain amount of hours. So for example, I am almost at the end of my hours for my current dual shield class, but if I were to finish and start my TIG class, like say tomorrow, I would still be able to burn my next week and a half of classes, those hours. Even though they're dual shield hours, I can start learning TIG. That way, when I sign up for TIG, then I'm actually a little bit ahead and I can start using up those hours. Okay. And then that's nice because once you're at TIG, you're at the end of the year. So once you're done with your assignments, you just have, who knows, 200 hours to just mess around in the shop. And that's pretty fun to do here. We got quite a few toys.
A lot of toys, okay.
Yeah.
So would you say
so basically, kind of to answer your question, from start to finish in the program that like Liam's in, usually takes about a year.
Okay.
We do have the degree program is a 2-year program, and with that one you have to take your general ed. You have your English classes and your history and all that goes with getting an associate's degree.
So if we were like talking about a project and we wanted to accelerate some learning and put people in a residential,
Right.
Just nothing but eat, sleep, and drink welding, you know?
Yeah,
Could you do that year in 6 months or something like that?
yeah, it's based on performance.
Yeah,
So
okay.
like Liam was saying, you get a certain amount of hours per class. Like I would say, for example, the oxyacetylene, I just know this one off the top of my head, is 120 hours that we allot to complete that course.
Okay.
You don't have to use up 120 hours. If if you come in and you hustle and you pick it up really quick, you might be done in 60 hours.
Okay, so it's based on proficiency
It's
then?
based on proficiency. So
Okay,
once you're proficient, you just move on.
Okay.
And we've had students that have gone start to finish in 6 months.
Okay, okay.
But they kind of come in, they might have had a little bit of a previous experience, or they just were naturally adapt to it and picked up on it real quick.
I remember Gabe, when you don't know him, he left before you started, but he actually took welding for 4 years through high school, and he was done with it. He was done with the entire stick unit in 6 weeks. Overhead, vertical, all positions in 6 weeks, and I was like, God damn.
Okay, that's good. All right, well, thanks for that
Yeah,
introduction.
and we do have I would say it's like a service learning department, where you can coordinate with them, specify a specific. Say you just wanted stick welders.
Okay.
I think, you're videotaping me, don't quote me on this. There might be a program where you can bring in students and just do that portion.
Right, okay. Specific training for specific tasks.
Training for a specific
Okay.
task, yeah.
So on this project, I can imagine, this is going to be an LNG plant. There's going to be a lot of pipe welding. You could focus on, pipe welding.
Right.
Certain materials and
Yeah.
really focus on that skill and get
yeah.
it 6 to 12 months to have somebody ready to go.
Yeah.
I would
Okay.
mainly focus on, if you're doing specifically pipe welding and especially pressure vessels.
Yeah.
Lisp came out.
That's right.
No, I would mainly focus on stick welding and TIG welding.
Yeah.
That's the absolute best for pipe.
All right.
Yeah.
Well, good. All right, thanks, guys.
Okay, well, you bet.
Appreciate it.
Well, nice to meet you again.
Nice to meet you. Take care.
Okay, so before I came here, I worked at Snow College in Richfield, and they had a program that's called concurrent enrollment, where they incorporate high school students into the college welding program. So basically, the high school students sign up for a shop class, sign up for the welding shop class, and they can come to the college at a junior and senior level. So they get 2 years of welding before they even get out of high school. A lot of them get certificates. If they're good enough, they can get a certificate and go right into the workforce. Or they have the opportunity to come to the college and continue their education and get their AAS degree. They kind of have the same thing here. The difference in Richfield is the high school is right across the yard. And so the high school students would actually come over to the college and use the college equipment. But they have concurrent enrollment sign up with about 10 different high schools. And the instructor at the college is responsible for maintaining the training level that the students get at the high schools. So the high school has their own welding teacher, but the curriculum that they teach is run by the college.
Okay.
And so as they're going through high school, they're actually getting college credits as well. And it's a really good program for younger people.
Well, just in my high school program, it wasn't super strict. I feel the hotter the iron, the better the steel, even though iron and steel are two different alloys. That's what my grandpa says. That he said it once, and I'll never let him not say it again. But yeah, my college or my high school experience rather with welding, it wasn't superficial. It was kind of like they showed me. I mainly learned stick welding and solid wire MIG, which were my favorite processes. And I didn't learn TIG. I didn't even know you could actually weld with oxyacetylene until I got to this shop. So that's why I kind of like a stricter program, because it's I didn't even know vertical or overhead until I got here. That was something or aluminum. That was something my other teacher didn't teach me. But as soon as I got here, I got exposed to everything, all of it. I've done.
How would you describe the mix when you were in high school welding? How would you describe the mix between regular high school classes and the welding classes? How was your time split?
I really enjoyed how my time was split. It took up, welding always took up half of my day, so my morning. And I would have a little time to get to school and have like an hour break basically after a class. So it was really nice for me, especially because I love working with my hands and I absolutely hate sitting in one spot for the same, for 6 hours or more. It's agonizing.
So you still got your high school degree?
Yeah. So I was going to Jordan High School at the time, but going to splitting my hours at CTech, which is the technical college nearby, and then I actually ended up graduating from a sub school off of that the CTech program. It was called Entrada High School. It wasn't even like a physical school. It was just on paper. So we like rented out cubicles and whatnot. But I got my I was behind about a year in my credits for high school, and doing welding and going to Entrada, I got all of that done in about 7 months, and was able to graduate with a fair amount of experience. So a typical booth, we got our manifold system. Most of our machines just use our 75 argon 25 O2 mix. Then of course we got our ventilators. These are a lifesaver because they save your lungs, but you will bang your head on it every day of the year. Let's see, we got our ground straight bolted into the concrete. We got our different clamp system. This is really nice. This can be used kind of in any position. You'll find out who has like Hercules strengths real quick when they tighten these in. You got to get a vice grip to get it off. Okay. No welding on the table, of course, just because it's a pain and it makes it harder to use for everybody else. Yeah. It's actually we'll clean them. I got my big wire brush here. You're actually supposed to clean the table with the wire brush every time once you're done welding. Otherwise, it's considered vandalism. Because imagine cleaning 120 something booths.
We got your Lincoln welder.
Yeah, we got this one's just running dual shield, standard Lincoln machine. We got quite a few controls on this bad boy, but I usually just stick with my two favorite knobs, the volts knob and the speed knob. Everything else is kind of obsolete. Although we do have hot start, arc control, couple other cool features. But yeah, I must say I'd say that's about maybe 5.5, maybe 6 feet. You don't need a ton of room, but kind of easier to turn your head in 5-foot booth than a 4-foot one. Alright, great. So these are our automatic acetylene torch cutters. They all run on a track system that can either be fabricated in the shop or just ordered with the part itself. They all come from the same manifold system, and they're pretty easy to work. All kind of a gear system. There's drive, which puts it in rolling mode. Of course, you can adjust the speed. And then you can click this down, go to free mode, where you can just move the torch, get your cut lined up how you need it. This knob here adjusts the angle of the bevel. Usually for our D grooves that we'll do bend tests on, we'll cut about a 30-degree bevel, 30 to 45 degree, and use that for our V grooves, and yeah. All right. So these are our freehand acetylene torches. These ones are kind of nice just because they have the cutting lever on it, which activates the oxygen. Of course, you got a constant flow of it, so you can actually weld with these as well as cut, which is pretty versatile. We got 2 main shears. Our big industrial one is currently not working right now, but that's used for cutting most of our...
That's your shear?
Yeah, that's for cutting all of our coupons. We'll do sheet metal with it sometimes, depending on what assignments need to be done. This is our one that all the students use. This one's pretty nice, our Piranha. It can cut it, wedge grooves rather. We use this main part here to cut the metal itself. And then if you, let's see, flip it over here to the other side, it has 3 different settings, but I just activated, which one did I activate? Oh, do they take off like that? Yeah, that's our, I forget what this part is called specifically, but basically it can just like chip out an edge out of a plate.
Right.
We got all of our plates organized throughout here. We go from 10 gauge, 3/16 to quarter if we have it, to 3/8, and then finally 1/2 inch, but we rarely get any of that in stock. Then of course up here you got aluminum, stainless, your different miscellaneous metals. Not too bad. Some people keep scrap over here. We're really close. So here's our grinding room. It is sealed off from the rest of the welding booths because of noise reduction. So it's a bit easier to talk to our students while we're in the booths giving demos of different things. All ventilated, same system. We got our 3 belt sanders. These are fantastic for just getting the burrs off. And well, I had to get a backing plate off for a groove weld that I had. And while these are good for just like fine adjustments on the material, I would use these, our bigger grinders, for like bigger pieces that need to come off. This one takes quite a bit off. I'll do that, polish it off. That one will get like the main bits off, and then this one will polish. This takes a second.
Okay.
So this is kind of nice. We'll buy our half vice grips, and these can actually screw into the table and make it quite a bit easier to clamp down metal to the table, so that you don't have to be just carrying extra vice grips everywhere. Saves students a lot of time, and every booth.
Okay.
So this is our submerged arc welder, and with the term like submerged, I thought that it would be underwater welding. No, it actually is done on very, very thick material to produce massive welds. That was done in one pass with this machine, and that's, well, it's about twice the size of my finger there. But so the way that this one works, same principle as all the other processes, except this one actually pours the flux coating onto it with kind of like a conveyor belt system. And then the metal is arced underneath this flux, and as it burns and as it cools into the base, this protects the metal and also keeps it from oxygenating and becoming brittle. So yeah, this machine is fantastic. We fabricated all these dividers here just for our different plates that get shipped in. These are actually it's really nice because our trucking program that's just like right across the way from us, we got a scrap bin, and then we'll just throw all of our already used material, and then they'll take it off to an area up in Ogden that processes it, rolls it back out to good usable plates for us, and then the trucking company brings it back too. So we get essentially free metal because we're just recycling our own stuff 24/7. Very efficient. It's our bandsaw. It produces the cleanest cuts, aside from plasma, in our shop. It's very messy. So how it works is you just raise this main piece up, and this is a oscillating saw made of tempered steel. And then so this actually, why does somebody max that out? I don't know. So you lift this up. Got to get to the end, otherwise you can't get enough leverage. You lift this piece up, and since I have the speed turned to off, you would start this. The blade would get moving, and it would also send. It's like a diluted mix of vegetable oil and water. It sends it down so it can lubricate the metal, so it doesn't either break the saw or, well, just make a bloody mess. But you're definitely going to need a catch bin for these. You get quite a few shavings out of it, so definitely something to consider. Just fine iron bits. These, I don't know a ton about them just because I haven't used them a lot, but they are essentially just for drilling pieces. You would place your bit in there, get it oscillating, and then punch it down. Not terribly expensive, very, very much needed. Let's see. So we have our plasma cutting booth here. It's just a very large table with cutouts, and of course we have our ground clamp and our plasma. I don't think it's on right now. Yeah, it's not on. That's all right. But plasma is very nice, especially for sheet metal, because it's actually a superheated gas, and it burns at 40,000 degrees Fahrenheit. So it can cut through pretty much any thickness of metal in well, basically instantly. And we got just, we only have 3 main sizes. These are all 70/18. We have our 5/32, our 1/8 inch, and then our 5/32. And these ones are about my favorite because they just cover everything. You can hide all your slag inclusions, all your porosity right under that weld.
Okay. Cutting practice plates there this year. You want to introduce yourself?
Okay, I'm Bob Udy. I'm one of the welding instructors at Salt Lake Community College.
Great. You want to show us the booth here and talk about it?
And our welding booths are all 6 foot by 5 foot deep, and they got lots of room in them. A lot of schools, their welding booths are a third this size, and these are really nice. They got room for the power source. If you look over here on the other side, you can see every one of our booths is supplied with a gas supply.
You got the gas right here, so you
We
don't.
buy our gas in bulk,
So you don't need the cylinders stacked out
so
all
we
over
don't
the
have
place.
we don't have to deal with cylinders.
Okay, great. Awesome. And there's your ventilation.
Yeah,
You got the ventilation.
There's our snorkel.
So they snorkel the gases out of here. And every booth has a snorkel like
Right,
that, right?
exactly.
Okay.